Hello everyone. My name is Dipankar Kindo. This is Altedemy, and today you are going to learn chemistry with me. Hello everyone. Good evening. Good evening, Ajay. Nice to see you. How's the connection? Can you please tell me? Is the quality of the broadcast? Can you score the quality, Ajay? Hello. Great, great. Thank you, Ajay. All right. Then let's wait for a few seconds for a few more students to come. Yes. Okay. And Ajay, please tell me how's your preparation going on for the exams? You can score your preparation based on the emoji score over here. Can you please tell us? All right, don't worry, don't worry. Yeah, two is great. You still have a few more months. So, and I'm always here, you know, to take your preparation to level three. All right, there's a problem with the focus. 1 second. Is the focus all right now? Yes. Okay. Let's move on. So let me tell something about myself so that you guys know uh, from where I come from. And okay, I have appeared for JEE exams a few years ago. Yeah, hello, Shubham. Nice to have you in our live session for today. And I've completed my JEE a few years ago. And I received 99 percentile in chemistry, and my score was uh, around 280 on an average for both JEE and mains. And my interest basically lies in artificial intelligence. Since I'm from computer science background, I'm deeply into artificial intelligence. And as you all know, the god of artificial intelligence, Elon Musk, is my really role model. And definitely seeing him work really inspires engineers like us. And definitely someday you guys are going to become a really important part of the society and contribute to the world. That is the actual main of actual aim of education. That's what we are. Yes, exactly, Shubham. It's a beautiful field. When you clear this exam, and then uh, no matter what your field, streams are all equal. Be it computer science, information technology, electrical, every field is same. The only thing that matters is your vigor, your zeal for the subject. That's the main thing. And if you have that, no matter you are in whichever field you are in, see, most of the the members of our this channel are the data scientists. See, such a beautiful subject. You'll get to learn more about it when you are in the field, when you'll be in the college. And uh, and see, that's how we propagate education. Yes, cybersecurity. Yes, that's a very great field, cybersecurity. For that, you'll have to know so many programming languages. Once you're into coding, you'll love it. You'll have to know almost all the programming languages. And based on that programming languages, you'll have to, uh, you know, uh, find the loopholes and become a white hat hacker someday, who knows. Okay, and that's how we are going to contribute to our society by our profession. Whatever we do in our life, we are contributing to our society. Even Elon Musk believes that. See, whatever he's doing, he knows that maybe not today, maybe not tomorrow, he will reach Mars. Everyone knows his aim is interplanetary, civilization. Yes, machine learning. Yes, yes. If you learn machine learning, based on that, you'll have to learn artificial intelligence, because machine learning is a part of creating artificial intelligence. Machine learning is basically, you'll have to train the computer to do a following task so that computer can learn how to do that task. Okay. So, and similarly, if you give it a very nice code, then automatically this machine learning code will create an artificial intelligence. And that's how Elon Musk has created the Tesla, the very famous Tesla. He knows that maybe not today, maybe not tomorrow he will reach Mars, but at least he has started today, so that someday our civilization can even go to some other planet. Anyway, keeping him as our motivation, as I keep him as my motivation. That's why I'm asking you guys to keep a role model for yourself and work hard. And uh, and today being our first step, and keeping that as our aim, today is our first step. And in our first step, you have come to this channel to learn more about chemistry, and hence today we'll be learning about equilibrium, ionic equilibrium. So I think we should get started. So first of all, by equilibrium, we all know, in English term, equilibrium means balance. You can, a synonym for equilibrium, you can understand it as equal, or similar, or balanced. Balanced will be more appropriate. So, uh, to understand equilibrium, in to understand equilibrium, what you have to do, this is the first example. So what we did is, we took a beaker, a flask, and poured water in. And then when we heat it after some time, and the condition is very important. The condition here is the flask is sealed. You can see it is sealed. This condition is very important. You will know it later. I'll even define it properly. The condition is that it should be sealed, and when it starts evaporating, the water starts evaporating, then after some time, in evaporation, we all know the state of matter changes. It changes from liquid. The particles from liquid turn, the space increases between the intermolecules, and thus they convert into gases. And when they do so, after some time, you can see the uh, concentration, the percentage of water starts to decrease. What you will observe, this is what you will observe with your naked eyes. After some time, after evaporation, you will observe that the concentration of water, the amount of water decreases. And what happens is, if you do this process very slowly to observe this, at a certain point, uh, the level of water stops decreasing. And when we look into it, when we know why this is happening, we'll understand that the molecules in the air, these molecules in the air are being trapped in this flask. So what happens when they are it is occupying more volume. In gas, it is occupying more volume, and it is applying a little bit of pressure. You can see this down arrow. This hello Meher. Yeah, you can see this down arrow, which means it is applying pressure on the level of the liquid. Easy way to do it. Bill Gates. Yeah. Yes, Subham. It's a very famous quote by Bill Gates. Because a person who has already seen the lowest knows what it will look like when he has the highest. You know. Yeah. That's why they are usually not all the time, but if you work hard, then obviously anything can be done. Either you are lazy or you are moderately working. If you work hard, definitely. And it all happens with step one. Every day, every single day, you'll have to take a step one. And what is that step one? You'll have to decide for yourself in which direction you will go in your future. It depends on that one step every single day. So this water vapor starts occupying more space in this flask, and that's why at a certain point after evaporation, uh, it comes in a stage where no more water can be converted into gas, and no more gas can be converted back to water, because it is in a pressurized flask. That's why what's happening is a dynamic change in state is occurring. At the surface, you'll be able to see at the surface of this water, a dynamic change is going on. That is, solid is sorry, my bad. Liquid is being converted into gas, and then gas is again being converted into solid. And after some time, this will reach a state where uh, the rate of change becomes constant, and that phase is known as equilibrium. Got it? Equilibrium. Yes, that was very simple part of this vast topic. And I know most of the guys will know this topic, but this is for everyone, this class, no matter he's starting that step one today, or your step one may be ahead of many other students, but that's what we teachers do. We treat every student equally, and step one is equal for all of them. Great. So next one is the extent of reaction. In this experiment, after this experiment, this happens in other equilibrium also happens in solids, and solids when submerged in liquid. So we'll have to understand the nature of this reaction. When does an equilibrium stage occurs? So when equilibrium, the reaction that proceeds nearly to the completion, and only negligible concentration of the reaction are left. It in this situation is still it is in equilibrium. Even the reaction of the even the reactants are about to be finished. What does this statement say? The statement says the reaction that proceed nearly to the completion. Nearly to the completion, that means it is about to be finished. If you have a water in a tight sealed container, let me make this more interesting. If we have a sealed container and it is constantly changing its phase, even if obviously when it is changing its phase, its concentration will decrease, and when its concentration will decrease, it's not exactly water. In this example, you can understand any solution. Even if the concentration decreases, that means the product is increased. The product here is, if water is being converted to uh, water vapor, then the water vapor is the product. The product here increases, but still this is in an equilibrium state. Okay, got it? And please guys, don't forget to take the screenshot of this notes. Obviously, we'll provide the notes later. If you subscribe to our channel on our subscribe to our channel and come and join our platform, we'll obviously be providing you notes. But just for your instance, for your ease, you can take notes from this slide. And the next point where the reaction can still be in the equilibrium is the reaction in which only small amount of product are formed. See, in this second drawing, in this second example, the large number of product is being created and very less number of reactants is here. Reactants and products, we all know, which is being used before the reaction takes place is the reactants, and what comes out after that reaction takes place is the product. So the reactance here is very less, but the product is more, but still it might be in an equilibrium condition. And the second stage is when, and the second stage where the reaction might be in an equilibrium state is when the reactants um, are more, sorry, let me change the color once again. If the reactant is more, the reaction didn't go very well. The transformation of state wasn't that good. But if we change the pressure, you can see that if the pressure is changed, then it can still, even this reaction can be kept in the state of equilibrium, because the uh, product, the water vapor is very less here, but if we increase the pressure, if this first drawing, if we take as the most stable way to form an equilibrium, then in this third way, if you use your logic, you will obviously understand that if we increase the pressure, even this reaction can be in equilibrium. So equilibrium, the state of equilibrium can be controlled by us. That's what human always does. He has controlled. Human always interacts with its environment and tries to change it according to us. And that's how technology came. We wanted our surrounding to be changed. We wanted our surrounding to be easier. That's why the first invention of mankind, the wheel was created. And even before that, you can say fire was the first invention. The stone tools, that was done to change the environment. And human is very keen to change their environment, and that's why we came to know that we can keep any reaction in the state of equilibrium by changing its other factors. Got it? And the third is the reaction in which the concentration of reactants and products are comparable when system is in equilibrium. See, where the concentration of the reactants and the concentration of products is equal, which is this first diagram. Even in this state, the definitely the equilibrium will sustain. So, what did you learn in this extent of reaction? Equilibrium can be sustained in any three ways, even if the reactance is less and the product is more, and even if the reactance is more and product is less, and even when the percentage of the concentration is equal. Got it? And by the way, guys, I have a little information and a little surprise for you all. The surprise here is we have a Telegram channel, and 10 lucky students, 10 of the students will get 1 month free subscription to our channel. Any of the 10 students. So please guys, you can scan this code and join our Telegram group right now, or you can take a screenshot and you can scan it later, but definitely join because it's a very good offer. You can get education in a very cheaper way. Okay, so let's move on to our topic. So since we are talking about equilibrium state, what happens is in the first example we saw the liquid was being converted into gas, right? So in physical equilibrium, what we are going to learn is the different phases where equilibrium can be sustained. Like equilibrium can be sustained when solid is being converted to liquid. Solid is being converted to liquid, and the equilibrium can also be sustained when liquid is being converted to gas, and obviously when solid is being converted to gas. We all know the examples really well. So in the we are first of all we are going to learn equilibrium in the physical process. So in physical process, what happens is the state of matter changes, right? Is it right or not, Shubham? the state changes in physical process. So even in this change of state, we can, you know, get a condition where the state is in equilibrium. While converting from solid to liquid, we can have a state where it is in equilibrium condition even in liquid and gas, solid and gas. Got it? Got it, guys? So first thing, since um, after this, the first thing that we are going to learn is solid to liquid. So how to attain an equilibrium condition when change of state occurs from solid to liquid? This is the main theme of this topic. So what happens is, let's take an example. Yes, we are going to definitely read this. Both the opposing processes occur simultaneously. That is, the dynamic change in equilibrium, solid to liquid, and liquid to solid, because it is a reversible change. Both occurs dynamically and simultaneously, and both the processes occur at the same rate, so that the amount of ice and water remains constant. To be in that stable state of equilibrium, both the processes, that is solid to liquid and then conversion back to liquid from solid, happens at the same rate. And we are going to see it in an example. So I'll give you a very short and simple example. Let's take a thermos. Okay. Assume it as a thermos. And here we have water. Here we have water and a cube of ice. Okay, and this is a very this thermos is not just a simple one. It protects the reactants and the products from any outward interference, from outward pressure or outward. That means we are basically, you'll have to understand that we are creating a very ideal circumstances for this circumstance, for this change in state. Got it? So everything is checked. This thermos is not allowing the outward interferences to affect the change in the state. That's what you'll have to keep in mind always while while studying equilibrium. So what happens is, after some time, uh, the water, the solid, the ice will start to melt. Okay, the phase will convert from solid to liquid. Okay, it will start melting, and at the same time, the because it is kept in a very ideal state, what will happen is even water will convert to solid, because the temperature this around this is very low because of the ice, and heat is transformed from one body to another body, obviously. So the temperature around here, the surface is very low. That's why even water is being converted to solid, that is ice. So at this place, we can observe equilibrium. Got it? We observe here as equilibrium, and that's why it is occurring dynamically. Now if you read the statements again, you will understand what I was talking. Okay, both the opposing process occur simultaneously. Yes, the state change from solid to liquid, and the liquid to solid. This arrow obviously means both the reactions are occurring at the same time. Both are happening at the same time. That's why we call it dynamic. In English, the dynamic means mm, rapid. That means moving. The best synonym for dynamic is moving. Static friction, dynamic friction, or kinetic friction, you must have studied in physics. It's like that. So dynamic means it is happening right now. And who was Shubham was talking about machine learning, right? So many processes happens in dynamic state only. What AI does is it. Are you there, Shubham? Are you there in the chat? Please let me know, because this is for you only, since you are interested in machine learning and artificial intelligence. I'm just telling you, just going out of my way and letting you know. So what it does is it dynamically accesses or understands what is going on in the environment, and then it changes its decision based on that dynamic. So dynamic means at the moment. So dynamically both the processes are occurring, that is both solid is being converted to liquid and liquid back to solid. So, and the next thing for this physical equilibrium is both the processes occur at same rate, so that the amount of ice and water remains constant. You won't be able to recognize by just observing, but if you observe it mathematically, you will know that both the occurrences, both the instances are being uh, occurred at the same time, and that's why no direct observable changes can be seen. Okay, so this was an example of equilibrium in physical objects, and in physical objects, solid was being converted into liquid. And in chemical, there are further we'll be learning in next class maybe, because we'll be conducting 3 classes on this equilibrium topic. And in just giving you guys a little bit hint that in chemical equilibrium, what happens is reaction takes place. One suppose nitrogen and hydrogen are mixed together to form ammonia. In that chemical reaction, what we'll do is find an equilibrium. Got it? So if you know physical equilibrium, it will be very easy for you to, get an idea in your head what actually is going on in chemical equilibrium. So this is just for your understanding, for a reference. In previous classes, I had given reference, uh, to make you guys understand the size of an atom. If you have seen the previous classes, have you guys seen the previous classes? Let me know. If you guys have seen the previous classes, I always give a reference so that you can see that reference and understand and apply it in real life and understand um, the intensity of or we can say the depth of the topic. So this physical state equilibrium we are understanding so that we can get a reference of what happens actually in chemical state. And definitely guys, please do not forget to subscribe our channel, because we are providing this in a free platform. We have free classes, and we also have paid subscription courses. But all the people who are enjoying this lecture in free classes, please do not forget to subscribe it, so that you'll get notification for our future free classes. And obviously, in a very famous dialogue from that Bollywood movie, Three Idiots, is that you should never stop learning. What was that dialogue? The dialogue was, "Gyan kahin se bhi mile to lapet lo." So if you're getting knowledge, please try to collect it. That's how. That's the step 1, which I talked about earlier, for every day. Got it? So the next physical state that we are going to physical equilibrium that we are going to learn is the change from liquid to vapor. Okay, to observe this equilibrium, that is equilibrium state from liquid to vapor, or we can say liquid to gas, a very interesting experiment was done. And the experiment was in a sealed container. Again, you'll always have to keep it in mind in equilibrium. The ideal condition is being observed. Again, we are using a sealed container. Got it? We are using a sealed container, and what we did in this sealed container is, you can see in this first diagram, anhydrous calcium chloride is present. And what is anhydrous calcium chloride? It is a uh, you know dehydrating agent. It absorbs H2O. Okay, and why we are doing this? To remove any water vapor particles, because we are going to observe it. So first of all, what we are doing is cleaning this setup, cleaning this sealed container, cleaning it from any particles of water vapor. And to clean it, we are using anhydrous calcium chloride. There is one more thing that you can use. If any of you guys are in class 11, you will know that in a chemical experiment, in your chemistry lab, you will do an experiment. In that experiment, another substance is used to absorb hydrogen. Sorry, not hydrogen, absorb water. And please tell me in the comments what is the name of that compound. And the other thing, okay, let's move on to the topic. The other thing that we are using in this setup is we are placing a manometer. What is this? This is the this is a manometer. And what is manometer comprised of? Obviously, you can see a YouTube, YouTube, a tube which is in the U shape, and mercury is put into this tube. And we all know mercury is used in thermometers to observe pressure. Thermometer and other similar objects, mercury is obviously used to measure pressure. In this uh, particular experiment, we are using mercury to observe pressure in this sealed tight container, so that even if a little change in pressure will be observed. Okay, so after a while, then what we do is we remove this anhydrous calcium chloride after some time, because we know that it has absorbed all the water particles from this tight sealed container. And then what we place in that container is a dish of water. So after and when we place it after some time, what will happen is evaporation will take place, and after evaporation, the molecules of water will start getting spread all around this vessel. I'm not doing this in blue because it will be tough for you guys to see it. So black is very easy to see, on a white page. That's why I'm doing it in black. And what will happen? And the uh, uh, concentration. By concentration, I mean the amount. The amount of water in this dish will, what will happen? It will decrease, because evaporation is taking place. The molecules are increasing its intermolecular space, and that's why it is occupying more volume. It is spreading out. The molecules of water are spreading out, and it is moving away from the dish. It is lighter, that's why it is moving away. It is not uh, contained in a bowl, and that's why uh, uh, the amount of water also decreases. And since the amount of particles are increased in this container, what will happen? It will also go into this U tube. The molecules will go into this U tube, and it will apply pressure on this mercury present in this manometer. And when the pressure will be applied, the the level of this manometer, the level of this mercury in this manometer will increase. And that's how we observe what is being occurred, what is happening. We observe that the pressure is increased, and yes, the pressure is decreased, and the level of water also decreased. Got it? So in liquid to vapor, this was a very simple experiment, and that's how we observed. And after some time, what happens is this level remains constant. How do we know it is equilibrium? Yeah, we understood that uh, the level in the manometer goes up. And how do we know that this is in a state of equilibrium? We understand this is equilibrium because after some time, this level won't change. It will remain constant. That means it will remain constant at this. And when it is constant, we understand that the pressure inside this container has become constant. That means, and when we know that the pressure is constant, that means we know that this reaction has come to a stage where the molecules of water are are in a dynamic state of being are in a dynamic state of interchange, that is from liquid to vapor. And how do we know this? When this level in this manometer becomes constant, that's how we know that this is in a state of equilibrium. Got it? The same thing can be done in other liquids as well if we use any other alcohol. And definitely, the equilibrium will always depend on the element as well. If we are using liquid, then if we use some alcohol instead of water, then obviously an equilibrium state will be reached, but it won't be exactly the other factors like temperature and pressure will be different for any other material. Okay, any other element. If you are using alcohol, maybe the pressure would be different. We'll have to provide different pressure for alcohol. For alcohol, we need different pressure and temperature. So these are the factors on which equilibrium always depends. So the factors are, keep in mind, pressure and temperature. These are the factors on which equilibrium depends. And moving on to the next topic, this is the third example of equilibrium in physical objects, and this is conversion from solid to gas. Solid to gas. What is happening is solid is being converted to gaseous state, and equally gas is being converted to solid. To observe this equilibrium, what the experiments are usually very interesting. The main skill is problem solving skills. What we require from engineers. You all are preparing for JEE, so obviously someday you all will become engineer, and to become an engineer you just don't have to mug something up and be there. What they're actually testing is how you are solving a problem. Any problem. There are many problems in your life. The problem, be it the problem is the problem can be very simple, from adding 2 plus 2. What is this? This is a problem, and what engineers do is solve it. How do we solve it? We get the answer for. Okay, this was a very basic example, but problems can be anything. The problem was the need of fire, the need of heat. So what humans created was fire to cook to provide heat, to provide warmth, and that's how to survive. How the early humans solved that problem? They solved that problem by creating fire. They had problem to eat, so they had to hunt. And to hunt, what they made stone tools. So basically, engineer is evolved early man, and evolved means very technologically advanced uh, uh, animal. So what we understand when someone calls himself an engineer is that he has a very good problem solving skills. So scientists, engineers, they solved this problem. The problem was in this experiment. If we take this context, in this context, the problem was we had to observe the change from solid to vapor, and we had to observe whether it can come to a state where it is equilibrium or not. It can, whether it can come to an equilibrium state or not. So what they did was, they took a container, and in a container they placed a ball of iodine. They placed a ball of iodine, and since iodine can easily convert from solid, iodine is a solid ball. So if we, when it starts converting to gas, what it does is it leaves violet fumes. I'm using this color because there is no exact option. So what it does is it leaves violet fumes all around this container, and obviously the state is being changed. So what we should observe is the quantity of that iodine must decrease. Okay, the quantity will obviously decrease if we place it somewhere outside. If we place this iodine ball somewhere in a normal, in a room temperature, after some time this iodine ball will leave violet fumes and then it will disappear. But since we have kept this iodine ball in a container, after some time, what will happen is this liquid, this fumes, these violet fumes will again pressurize. This will be under pressure. So again, what will happen is state will change back from gas to solid. Back from gas to solid will occur then, and after some time, and when this iodine starts emitting violet fumes, at first the intensity is very dark. The intensity of the fumes is very dark, you know, because it is being converted, and when being converted to gas it leaves violet fumes, and at first when it starts to change from solid to gas, the intensity of violet color is very thick, it is very intense violet. But after some time, when the pressure on the molecules are exerted because of this closed container, it exerts pressure on the molecules, then after some time the intensity of the violet fumes becomes lighter. It becomes lighter. The intensity becomes lighter, and after some time you won't be able to see any dark fume. You will only be seeing these light fumes, and after some time, and this is what will happen. Okay, and how do we know that this reaction is in an equilibrium state? We'll observe it when after some time the intensity decreases and it's the same. It's the same. The reaction becomes constant. It won't be converting to solid at a very high rate, and solid won't be converting to a low rate. The color, basically we observe it is in equilibrium when the color becomes light. So when it becomes light, we know that the intensity, the rate of conversion has decreased, and now it has reached a very stable state, and that is the equilibrium state while conversion from solid to gas. Okay, and dry ice is also an example of conversion from solid to gas. We can see in this image that dry ice, when kept in a room temperature, leaves white fumes. Dry ice is basically carbon. You'll get, excuse me. Okay. So next thing that you will learn is equilibrium involving dissolution of solid or gas in liquids. First, what we were studying each element individually. That is, solid was being converted to liquid, and liquid was being converted to gas, and vice versa. And now, what we are going to learn, the equilibrium state when solid is mixed in liquids. Okay, and to study this state of equilibrium, the experiment that we perform is we create a lemonade. Simple. When life gives you lemon, make a lemonade. Not exactly lemonade in this experiment, we are making a sugar solution. So, sugar is a solid element in this reaction. In in this reaction, sugar is solid and water is the liquid element in this reaction. So when we add sugar in this solution, what we see is if we mix it, we start mixing that sugar solution, the sugar particles will start getting mixed with the liquid. You know, it starts getting dissolved. That's why we are studying dissolution of solid or gases in liquids. Gases we'll learn later. In this example, we are learning solids in liquids. We are dissolving solids in liquids, and the sugar starts dissolving in this liquid. Okay, and after some time, what will happen is no matter how much sugar you add, it won't be dissolved. You can see it starts forming crystals. We'll also have to heat this water a little bit. If we heat the water, if we heat the water, that the reaction will take place faster. And yes, after some time, what will be after heating some time and then mixing sugar in this liquid, what will happen is you will be able to see sugar crystals in this liquid. And and that means it reaches a saturation state. And what does this saturation means? The saturation state means that no matter how much sugar uh, you put in the liquid, it is not going to dissolve. That means it has reached a maximum level of getting intermixed. So unsaturated means it is not mixed, and saturated means it is 100% mixed. In this, it is 100% mixed, and in unsaturated, 0% or a slightly mixed, I can say. Got it? So the next what we are going to learn is gas to liquid, gas in liquid. When gas is mixed in liquid, how to come to a state of equilibrium. The mass of gas dissolved in a given mass of solvent at any temperature is proportional to the pressure of gas above the solvent. Got it? Even if you didn't get it, I'll explain it to you. What happened is, I'll explain it to you with the help of an example. We all drink carbonated drinks like Coca Cola or Mountain Dew. These are all carbonated drinks. What we do is, in this bottle, we mix, please don't mind the drawing. In this bottle, there is a drink, and then explain which topic, Shivika, which part do you want to understand? This gases and liquids, I guess. Yes, I'll explain the this definition once again. Don't worry about that. This is just a statement. I just want you to read the statement with me. Okay, so read the statement, and then when I'll explain the example, you'll know what this statement actually means. So the statement is, read it with me. A mass of gas dissolved in a given mass of solvent at any temperature is proportional to the pressure of gas above the solvent. So after you read that statement, see this experiment. We all drink Coca Cola. Let's take example. It's a very huge company. We can't sponsor. They can't sponsor us, obviously. So we are taking their name, Coca Cola. What they add is they add carbon. They are mixing carbon, which is gas. They are mixing gas in this liquid. And how do you assume that they would mix gas in this liquid? The only way is by applying pressure. They have, in Discovery channels, they used to show how the factories are made. In Coca-Cola factory, you must have seen there are huge machines that apply pressure and then seal the bottle, put the liquid in it, then seal some gas in the bottle, and then seal it tight. So what they are doing is they are applying pressure. Again, this factor has come. Never forget this factor, pressure. What are those factors? Please tell me, Shivika. The factors, they are applying pressure. The pressure, with the help of pressure, they are mixing carbon molecules in this liquid. So that's how we are mixing. We are mixing it in with the help of pressure. The mass of a gas dissolved in a given mass of solvent at any temperature, mass of a gas. That means a certain amount of carbon, a quantity of carbon in a given mass of solvent. The solvent being the drink, whatever the drink it is, the solvent being the drink at any temperature is proportional to the pressure. That means the amount of pressure you apply on that gas, that is the rate, that is directly proportional to the rate of dissolution of gas in that liquid. Got it? So if you increase more pressure, more quantity of gas can be dissolved in the liquid, and if you apply less pressure, the less amount of gas can be dissolved in the liquid. And that's why, remember, whenever you open a bottle, you hear that fizz, because it is tightly sealed with high pressure, so that the carbon is nicely mixed in this drink. You can get the feel of that soda, and that's why it is highly pressurized. So when you lose the bottle, that means you are allowing the pressured gas to escape, and when you lose it a little bit, it is placed with such high pressure that even if you lose it a little, it comes out vigorously from that bottle. It comes out vigorously, and when it comes out vigorously from that bottle, due to very narrow path, the gas is coming out from very narrow space. That's why it makes sound, because the molecules are hitting very closely and they are coming out in a rush, in a very fast, after every when the classes end, when your school ends, everyone just gets stuck in the gate. So that is the rate, because everyone wants to go home after 6 hours of school. So they rush into the gate, they want to come out. And similarly, because it is in high pressure, the gas is in high pressure, it rushes and wants to come out. And that is the main point. It makes fizz. So what we are learning here is gases can be mixed in liquid, and then it can come to a state of equilibrium. See, because equilibrium, to come to this state of equilibrium, we are mixing it in a proper state, so that again, when we seal it tight, what is happening is the molecules inside this bottle, the gas is pressuring the liquid, and the CO2, which has already converted, which is already mixed in the liquid, also wants to turn back to gas. But the pressure is such quantity that it is not allowing the carbon in the drink to convert back to the carbon in the gas. Got it? So that's how we create an equilibrium state, and that's why you are able to enjoy the taste of soda in whatever drink you are drinking. Because if if this is not if just assume that in a drink, in a Coca Cola drink, there uh, in this container, they are not applying very much pressure. Okay, they are not making an equilibrium condition and pressure. That means the molecules will be in the gas only, the carbon will be in the air itself. It is not properly mixed, it is not in a stable condition, so only few particles are in the liquid. So when you open the bottle, the gas will come out, and since the pressure was very low, the carbon is not mixed in the drink. So when you drink uh, that soda, you won't feel the carbonation in it. Got it? Because it is not in an equilibrium state. It wasn't mixed properly. So a good drink is made only when in an equilibrium state, carbon is mixed in the drink, so that neither the gas is very low or the gas in the bottle is very low, nor the gas in the liquid, the solution is very low. That's why we have to study equilibrium. We have to create an exact amount. So now suppose we have understood that the pressure is 2 bar. Just for example, I don't exactly know how much Coca Cola uses. If this is an exact amount, then definitely they will sue me, because they have many secret ingredients. Anyway, they will not sue me, obviously. What is happening here is, suppose the pressure is 2 bars, or there are two quantities to measure pressure. It is in bars, or either in bars or in atmospheric pressure. Atmospheric pressure, we write it as ATM, or the other unit is bar. Suppose we need 2 bar of pressure to create an equilibrium of carbon dioxide in this soda. That means we have calculated the pressure to create an equilibrium. That's why these factors are very important. If we didn't know the factor that equilibrium depends on the pressure, then how Coca-Cola would have come to this number, and they would have created such a beautiful drink which tastes really well. Every time you eat a pizza or you eat a burger, you need a Coca-Cola in your hand. So that's why the drink is very tasty. So science made that drink so tasty. The problem was you needed a good drink, and the problem was solved with the help of this scientific method. That means they created a state of equilibrium with the help of the factors that uh, help create an equilibrium. The factors being pressure and temperature. In this situation, the temperature doesn't matter. It matters a little bit, but not so much. So the pressure was the main factor in this. Not exactly. I don't think it actually depends. Yeah, my bad. It doesn't depend on the temperature. It actually, when gas to liquid, it only depends on pressure. And previously in this example, we used heat. In this example, only when solid is being mixed to a liquid, the main factor is heat. Let me write it again. The main factor while converting solid, when mixing solid and liquid and creating an equilibrium state, the main factor is heat. And similarly, when in gas, when mixed in liquid, the main factor is temperature. Got it? Should I write it for you? Yes, obviously I'll write it for you guys. The main factor in this gas mixed in liquid equilibrium is temperature. And what was the main factor when solid mixed in liquid is heat. Got it? So the features of physical equilibria is just a plural form of equilibrium. Don't get panicked. These are the basic features what we have learned in this previous slides. I have summed up and given it to you in a compact way. So what you have to do is understand this only. So solid in a reversible change with liquid equilibrium, melting point is fixed at constant pressure. I remember that experiment where ice was kept in that thermos. So it depends on the constant pressure. Liquid to gas, the vapor pressure is constant at a given temperature. Remember that experiment with that manometer and anhydrous calcium chloride. The vapor pressure, uh, uh, when the vapor was in that container, it was applying some pressure on that liquid. That pressure is vapor pressure. That pressure is vapor pressure. The vapor pressure is constant at a given temperature. When you keep the temperature constant, the vapor pressure will also become constant. And the third thing that we learned in physical equilibrium was for dissolution of solid and liquids, the solubility is constant at a given temperature. So in this previous experiment where we, converting when we were mixing sugar into the solution, it depended, the solubility was constant at a given temperature. We were giving it heat at a particular amount of heat. The sugar solution will form crystal, and then it will come to a stage of equilibrium. And the fourth thing that we must know is for dissolution of gases in liquid, the uh, concentration of gas in liquid is proportional to the pressure of the gas over the liquid. So finally, the soda experiment. So in all the experiment, remember it with the help of experiment. That's how you will know. With the help of reference. You can't just learn the table of 12 at first and you will able to, you can obviously mug up, but if you relate it, that's why you'll be able to keep it in your mind properly. There are two parts of your brain, short memory and long-term memory, short-term memory and long-term memory. So if you relate something with any object, and from a real world entity or from your experiment, the best thing to keep any topic in your long term memory is to relate it with any topic from your experience. That's why it is called experience is the best teacher. You must have heard this saying. Why experience is the best saying? Because with your experience, you can learn new things. You can relate new things with your previous experience, and it will be stored definitely in your long-term memory. And short-term memory is like a cache memory of any CPU, where it keeps stores it for a while and then removes it. That's why these features are very important for physical equilibrium. And for each feature, I explained you an example. In the first feature, the example was a piece of ice was kept in a thermos. The second was liquid to gas. For the liquid to gas, we did was that manometer experiment. Water was being evaporated and then pressure was being checked with the help of manometer. The third, dissolution of solid. In this, what the experiment was? The experiment was we were mixing sugar into the solution, and finally for the fourth, we were mixing gas, carbon dioxide in our favorite drink, Coca Cola. I am saying it again and again. I don't know if Coca Cola decides to sponsor us. It's very silly, but anyway, general characteristics of equilibrium. Equilibrium is possible only in closed system at a given temperature. The two factors was which I spoke about almost 100 times in this session. The equilibrium is possible only in closed system. That means by closed system means pressure is being checked. What is being checked by closed system? Pressure is being checked at a given temperature. These two factors are very important. Both opposing processes occur at the same rate and they are dynamic but stable in condition. By dynamic, we know that both the change of state from solid to liquid or liquid to solid is occurring at the same rate. That means the amount of molecules converting to vapor and the amount of molecules converting from molecule to solid are the same. That means the rate is same and it is occurring dynamically. That means at the same time, both the process, solid is being converted at the same time when solid is being converted to gas, at the same time when gas is being converted back to solid. All measurable properties of the system remain constant. All the measurable properties, measurable properties like heat, pressure remain constant. When the equilibrium is attained for a physical process, it is characterized by constant value of one of its parameters at a given temperature. When an equilibrium is attained for physical process, it is characterized by constant value of one of the parameters at the given temperature. So the constant value will be pressure. So it is characterized with the help of pressure and temperature only. All these things lead to one thing. You will learn this in NCERT as well. They will, ask it in your CBSE exams. The main thing is they may write it in any way, any sentence. But the main thing that you have to understand is equilibrium depends only upon pressure and temperature. The magnitude of such quantities of any stage indicates the extent to which the physical process has proceeded before reaching equilibrium. So what this means is the magnitude of such quantities at any stage. That means what we are observing. That means in the example, a liquid is being converted to gas. In that example, we can observe the magnitude. That means the quantity of liquid, and by observing that quantity, the change in quantity, that means when liquid is evaporating to gas, the quantity of the liquid decreases. By the change in the quantity, we understand that the reaction is taking place, and by controlling that change of reaction, by controlling that change, we come to a stable condition, which is equilibrium. Got it? I hope you guys got it, because I tried my best to understand, to help you guys understand it in a very simple way with beautiful examples. And that's all for today. And definitely, since we have learned about equilibrium, and I would like to tell you guys about our platform, where we are providing not only this but many more courses, 90 plus classes. And by classes I mean not only webs, there are physical homeworks, there are physical notes and everything. And we really offer convenient education platform. Like we have our own website named altedemy.com. It is the link is in the description. Obviously you guys can go and check it. You can check the prices of different courses and select any course which suits you. And the syllabus for from JEE experts, that means the syllabus is created by us, and not only me. It's not only input from one person. We have consulted the syllabus from many experts, and then we have come to a conclusion that this is the best way of teaching the students. This will be the best pattern to teach, so that the students can gain maximum marks in very less amount of time, because these are the factors you will need to crack JEE: time and quantity. So the quantity, we keep it in a way such that you can complete it in least amount of time, or the in a very ethical or very beneficial way of time. Flipped classes method. This means flipped classes methods. We provide classes in many modes. I'll talk about it in the next slide. And doubt solving practices. Obviously, we provide one-to-one mentorship as well. If you select a respective course for it, and by this flipped classroom method, which is a very good technology. This technology is currently being used in even in great universities. The Q2 ranking there is always every year in the world, there is a Q2 ranking which measures which college, which university is imparting great knowledge. Shivanand, hello Shivanand, you are quite late, but no worries, you can obviously view this in YouTube for free. Yeah, it is 1 second. Yeah, it is going to be over. I'm just talking about our classes. These are the various modes we provide. First of all, in this process, what we do is before the class starts, we provide the students with theory and study materials. Got it? So when you have the theory and study materials, you know the topic, what we are going to talk about in the class. The next thing is webinar, that is the class that will be conducting live. So you are not sitting there ideal, you are not sitting blank in your house, assuming that whatever he's teaching, I'll learn it simply. And that's not the best way to learn. The best way, and the best way is this method, which is being used in Harvard and IIT Delhi and great institutes like that with a very high Q2 ranking. You can check what is Q2 ranking. It, arranges it makes the ranks of the best colleges or university. Even such great universities use this type of education. So after the then after providing the study materials, you know what is going to be talked about in the class, and then when you come to class, everything is very clear to you, everything is crystal clear. And then after doing homework, you will the main point of doing homework is to apply whatever you have learned, and to know whether you are applying it correctly or not, we even provide homework checks, so you will know what you are making wrong, what you are doing wrong, and what you need to correct to score maximum in your JEE and to get a best university for your further education. In India, we know everyone comes from a different financial background. So what we did is we divided our courses into 3 categories, categories being light, smart, and professional. And for each category, the students can access different kinds of materials. In the light, the students can access interactive live classes, which we create on YouTube, which is a free platform. You can learn from YouTube, and structured courses and PDFs. The homework section is also given in our website. From light course, you will be receiving structured courses and PDFs. The whatever we will teach, you will receive that. Live tests. We also conduct tests for the students who will be taking this package, this light package. And not only that, physical notes will be given to you for all the students who will be opting this light package. And the other package is the smart package, which provides even more features like one-to-one mentorship. You will know what you are doing wrong. You will have a guide who will tell you what you are doing wrong and what thing you need to improve in your learning process. We have live doubt solving classes in this package, where you can ask the teachers directly what the problems you are facing, and the teachers, of course, will help you solve it in a most simple way. We also provide mock tests regularly, and mock tests, is very important. If you are applying for JEE Advanced, JEE Mains, you can obviously, crack it. And even for JEE Mains, you need to give mock tests. Mock tests are very important. And we provide mock tests in the smart package, and in the professional package, additional special courses. You will know more about it from our website, which is in the description. So please guys, go and check it out. And that's it for this session. There are other teachers, very great teachers, very experienced teachers for physics and mathematics as well. Please go and check their courses as well. And that's it for all. That's it for today. And thank you, everyone. That's it.